Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next module, problem number 5, fluid mechanics. Okay. First, we come to our statement. A 50 kilogram woman wearing high heeled shoes is invited into a home in which the kitchen has vinyl floor covering. The heel on each shoe is circular and has a radius of 0.500 centimeter. Part A. If the woman balances on the heel, if the woman balances on one heel, what pressure does she exert on the floor? Part B. Should the homeowner be concerned? Explain your answer. Dear students, here part B is basically not our very concerned matter, because many things are involved due to which we have to go beyond basics of this chapter. Okay, anyhow, we will try to answer also part B. Dear students, here one thing is that radius is given in centimeter. We usually follow MKS system, so we must convert this radius in meter, which will become 0.005 meter. Okay. Anyhow, we come towards its solution and everything will become clear. Okay. We first start as in our previous 4 modules, okay, from the definition of pressure. Okay, we know that the pressure P in a fluid is the force per unit area exerted by the fluid on a surface. Okay, P triple line F over A, that is pressure is defined as force over area. Okay, dear students, these 3 lines may be treated as equivalent to equal, but various similar symbols are used in physics which have slightly different meaning. Okay, so first we come towards the table in which such symbols or similar symbols are given, so that we may remove this confusion. Okay, this is the table. Mathematical symbols used in the text and their meaning. Okay, first symbol is equality, is equal to. This is quite simple. Then these 3 lines, 3 line symbol is defined as, okay, these 3 line, when we write something with 3 parallel lines, then it stands for is defined as. Okay, so is equal to or is defined as or is equivalent to are almost same, they convey the same sense. However, I deemed it appropriate to show this table. Okay, pressure is defined as force per unit area. Okay, in the SI system, pressure has units of newtons per square meter, that is capital N over small m square, and 1 Newton over meter square is equal to 1 Pascal. 1 Pascal is the unit of pressure. It is abbreviated as PA. Okay. Using here, dear students, in place of F, we will use, according to Newton's second law of motion, F equal to mg. Okay. Using F equal to mg, A equal to pi r square. Okay. Here, in place of A, we will use formula for area. Dear students, formula for area varies according to different geometrical shapes. Here, the shape is circular. Okay. So, we will apply the formula which will apply to a circle, area of a circle. Okay. Area of a circle is calculated as A equal to pi r square, where r is radius and pi is 22 by 7, and we take it equal to 3.14, and we have previously mentioned many times that decimal representation of pi is non-repeating, non-terminating. It goes endlessly, but we have restricted its value up to 2 digits. Okay. So, in this equation number 1, we will use F equal to mg. According to Newton's second law of motion, area equal to pi r square. Here, F equal to mg, m is given 50.0 kilogram. G is a constant, acceleration due to gravity 9.8 meter per second square. Pi is 22 by 7, 3.14. Okay. R is given as 0.500 centimeter, but because we follow Ampere system, so we convert it in meter, which will become 0.005 meter in equation 1. Okay. That is, in equation number 1, we will use all these values. Moreover, by definition of Pascal, which is unit of pressure, 1 Pascal is equal to 1 Newton over meter square. This alternatively becomes equal to kilogram per meter second square. This alternatively again becomes equal to 1 joule per meter cube. Okay. However, to the extent of this problem, we are not concerned with this last equivalent value. Okay. We are concerned only with the kilogram per meter second square. So, pressure P equal to F over A equal to mg over pi r square equal to 50.0 kilogram into 9.8 meter per second square over 3.14 into 0.005 meter square. This will become equal to 490 kilogram divided by 0.000785 meter second square. Okay. This alternatively becomes equal to 6242038.216 kilogram per meter second square. And here we know that kilogram per meter second square is equal to Pascal. Okay. So we can write it in this form as 6.24 into 10 raised to the power 6 Pascal. Okay. In place of Pascal, we can also write Newton per meter square. In place of Pascal, we can also write joule per meter cube. Okay, but this is quite enough when we answer it in shape of Pascal. Even if we answer it as this value Newton per meter square, then again it will be quite okay. We are not bound to convert it in this form, that is 6.24 into 10 raised to the power 6 Pascal. Okay, 10 raised to the power 6 usually stands for mega. Okay, so we can also call it as 6.24 mega Pascal. Okay, now we come towards part B. Part B answer is yes. Homeowner should be concerned and should request his or her that is homeowner is if male, then guest will be his guest. If homeowner is a female, then his guest will be her guest. Okay, and should request his or her guest not to balance herself solely on single heel, because more pressure exerted by single heel in this way may damage the vinyl floor covering of kitchen. Okay, so, this is a very minute thing, we should not explain it in detail, meaning that homeowner is likely to cause a minor damage because his or her guest balances his weight on a single heel, and due to excessive pressure vinyl floor covering is damaged, and homeowner has to expend some money to for maintenance of floor. Okay, now we have already shown this table. Okay, now we come towards the reference book from where we have chosen this problem. Reference book is Physics for Scientists and Engineers with Modern Physics. Authors are Raymond A. Survey and John W. Jude Jr. Publisher is Cengage, and its 9th edition 2014 has been followed or adopted, and its chapter number 14 under title Fluid Mechanics is our concerned chapter, and this module is included at serial number 3 of this chapter's exercise. Okay, that is exercise number 14.3, and this is the end of our module, our problem. Okay.